Welcome to this video. In this video, I am going to talk about spin resolved electronic band structure and density of states for bulk ghost. In the earlier lecture, I told you that how high symmetry points identified using XMGRACE. So let us start. Here in this lecture, I would also like to tell you that how band structure plotted using Gnu Bands and XMGRACE utility and density of states plotted using FMPDOS and XMGRACE. So let us start. So let us have a brief look at Ftf file which I used. So this is the experimental lattice vector which I am using. Lattice constant, these are the lattice vectors. Now let us go to the high symmetry points which I have chosen. So these are the high symmetry points which I identified in the lecture using XMGRACE. So this is gamma point, this is H, this is P, and this is N, and then gamma. And K grid mount cost pack which I have used, it is 15 by 15 by 15. Then this is a block for projected density of states which is needed. So now if I run this, you can run this FDF using this command, right? So I already run this. So when I run this FDF, I got these various files. So my main focus is to describe this file containing information of projected density of states and another file which is needed, that is .bands file. It contains electronic band structure information. Now we have to use two utilities which are needed. I told about these utilities in the previous lectures. So there is one directory here, bands. I compiled it earlier, so I will use this utility GNU Bands. So I copied this utility in user local bin as I told earlier, and then after this I will try to look at another utility, that is in the contrib apostrophe code. Then here this is the utility FMPDOS. So I will use these two utilities. So first of all, I will use GNU Bands utility I will use GNU Bands Utility. So it will convert .bands file into a data file, and which can be plotted, because .bands file cannot be plotted directly. So my purpose is to convert into another format so that it can be plotted. So I am making a file bands.dat. Give some error. Okay, this should not be there. There is some error. Oh, sorry. This, and then right. So now let us have a brief look at both the files. So one file is feb.bands file. In this file, this is the Fermi energy, and this contains the energy range, and in the end of it contains information of high symmetry points, location of high symmetry points, right? So our high symmetry points are located at these positions. So these are the location of these high symmetry points. This is gamma point, this is H point, and after H it is a P point, then N, and then gamma. So these are the locations of high symmetry points, and the Fermi energy will be -8 point. Fermi energy, it will be -8.715173, right? So these points are needed. And then let us have a look at bands.dat file which I made. So this is a bands.dat file, right? It contains information. So this is the K column. This corresponds to energy. We have to plot E versus K graph, or K versus E graph, and this one represents the spin, and after it there is spin 2 information will also be there. This is for spin 2 information, right? So we can do another thing, that is, if we use GNU Bands Utility for this, and if I give a command for spin result, means if I use, say, -S1, means it corresponds to spin 1 information, so it will extract information corresponds to up spin, right? So these are the changes which I made here, additional, like this and this, because this is just for the identification, right? So, and similarly, if I want to extract information for spin 2, then if I make changes in this manner, this will extract information for spin 2, right? So I resolved band structure, or I extracted information from .bands file for spin 1 and spin 2. Now let us try to plot this XMGRACE. I did one thing, that I arrange graphs. So let us do one thing, say 2 columns and the 2 rows, and I will explain it that why I am doing it in this manner, right? So say in this plot, I selected this plot and then go to data and then import. And if I import it, let us have a look at .dat file. So I am plotting for band structure for spin 1, and then I am plotting band structure for spin 2, right? Then what I will do, I will try to set Fermi energy at 0. So I selected this graph and then go to data, then transformation, evaluate expression. Then I selected left side and right sided data. Then I put formula because y is equal to y plus the value of the Fermi energy, and the value of Fermi energy for this system is minus 8.715173. So this is the Fermi energy. So I shifted Fermi up to 0. Similarly, for spin 2, I selected this second graph and then selected all these data points on the left and the right side, and then again apply the same formula because both have the same Fermi energy, right? Now Fermi energy set at 0. So if Fermi is set at 0, then I try to look at the band structure. So I go to here and then change axis from -10 to +10. And here you can adjust major spacing. Let us take it as 4. And similarly, it is -10 to 10. Then in this manner, and let us make it little bit bold, and you can change the color. Say it is black. Now again I am changing the, so this is the band structure for bulk iron. Now I will plot high symmetry lines here. So I selected this graph. So this is gamma point and this is another gamma point and another gamma point. This gamma point is at 3.560247 as I stated here, right? So for that, what I will do, I go to the axis properties, then select x-axis, and in place of this, what I will do, I will make it as 3.560247. Then I selected another graph, and here again it is 56047. So now it is at, right? Now I will, so this is gamma point, this is gamma point, this is gamma point, and in between there I can plot another gamma points. And there is no need this scale along x-axis. So sorry, so I replace these data points by clicking on display tick levels. Then I have to plot lines. So go to window here and drawing objects. Then one line is at 1.15, so 1.1 line will be somewhere here, and it is H, and there is another line P will be somewhere here, and then another high symmetry line or high symmetry point gamma at this point, right? Now I will adjust these. So I go to the edit object, then click on this line, a window will open, then here use word coordinates. So here the value of H point is at 1.158508, and Y varies from -10 to +10, and here it will be 1.158508. So this is high symmetry points, and let us change its color and let us make it dotted. Similarly, we can adjust another line. Say now I selected this and put it here, word coordinates, and then another high symmetry point is P. It is 2.161805. This is again -10 to +10. It is 2.161805, and this is +10. This now again change the its color to distinguish. So this is P point, high symmetry point P, and let us edit another line, this one. This corresponds to N, and N is at 2.74 2.741059. It's again -10 to 10 by, and it's 2.741059. It is +10, right? Then again I can change its color. So this is a high symmetry point. Then let us put some text. Say it is gamma point, so let me xg, say it is xg /xg, it gives us gamma. Then again I put gamma point here by clicking on it as /xg. So better we will use word coordinates always, and let me reset it using move little bit here so that things will be more clear. Then again I go to the edit object and put its coordinate as bird coordinates, then move object again to make it visible. Then I again go to here, right click on it at this point where I want to place H point. Let me adjust it. Yeah, so it is a H point. Then again go to the edit string and then put P point here. But before that, let me use word coordinates, right? So it's a P point. Similarly, another point will be N point, and let me readjust these. So it is the K axis and it is the energy axis. So this is the band structure for up spin. This is for up spin. So for sake of simplicity, up spin, let me write down it here, up spin. Right. Now similarly, I can plot the band structure for down spin. So I am doing this quickly in the same manner. This is one line, this is another line, and this is another line. Then go to the edit objects in the similar fashion using bird coordinates. So it is 1.158508. It is minus 10 to 10. 1.158508. It is plus 10, right? Then I reset the color. Then I go to here, again word coordinates. It is 2.16, 2.161805. It is minus 10 to 10. 2.161805. This is another. Let me make it a little thicker. And then I go to the third line that corresponds to N. And bird coordinates, it is 2.76, sorry, 2.74, 2.74, 1059, minus 10 to 10, because my Y scale is from minus 10 to 10, so it is 2.74, 1059, it is plus 10. So this is the band structure. Now let me draw Fermi energy or the Fermi level. So for Fermi level, I will draw a line in this manner. Then again go to the edit object, and here word coordinates. Say Fermi energy is set at 0. The value of the x will be 0. Y will be 0, and here the value of x will be 3 point, it is this 3.560247. Then its value will be again 0, right? So this is with it how I can draw the Fermi level. This is Fermi level, and let me represent it with another color. Say it is a green color. So it is Fermi energy, right? Then again I selected first upspin graph, and here I can plot again Fermi energy or the Fermi level. So let me go to the line and then plot it. Then edit object. So how this object will be, so its coordinates will be 0, its coordinate is again 0, and its coordinate will be 3.56247. Now I go to here, it will be 0. So this is a way that how I plotted the band structure for up spin and the down spin. So this is for the down spin. This is for the, oh, sorry, there is some problem with it. Yeah, I have to select first of all this graph and then use bird coordinates and then write down here down spin. This is for the down spin. Yeah, this is for the down spin. Or what I can do, I can put it here. This is for up spin, and do one thing, and let me move this. Okay, sorry. Yeah, it's for the down spin. Now here in this side I will plot density of states. So for that, what I will do, let me first of all save this. I can save it as band underscore DOS dot AGR. This can be saved in this manner using AGR format, right? So it can be saved. Now let me go to again to the terminal. Yeah, sorry, this is the terminal. Now there is a file named FMPDOS. So I can convert this into the format which can be plotted using XMGRACE or some DAT file. So I will use FMPDOS utility. Enter what is the name of the input file. The name of the input file will be this one, right? I enter. Now what type of DOS? So I will use the command DOS.dat, right? Now extract data for atom index or atom number. So if our system have more than one atoms or different species, then I can extract data for those species also. But here in our case, we are having single atom or one type of atom. So if I want to select all, then I have to give enter. Sorry, I have to give the value 0 to select all. Then n. So it is a principal quantum number n. So I want to plot the total density of states. So I put it at 0, right? So here DOS.dat file will be there. This DOS.dat contains information. This contains energy along x-axis, and this is the density of states corresponding to spin 1 and spin 2. So this is for this second column for spin up, and this is for the spin 2 or the spin down, right? So when I am plotting density of state here, what I will do, when I am plotting density of states here, so what I will do, say it is energy axis, so it should also be energy. So that means I have to change the axis. So this is for spin 1. So for spin 1, I will go to the import, and here import that where is the DOS.dat file. Yeah, it is the DOS.dat file, and here in place of single set I go to the block data and then click on OK, and after that along x-axis what I need second column along x-axis, and along y I need energy. So that's why I am putting y as this. So this is corresponding to spin 0. So I apply it. So this is the density of states corresponding to it. Similarly, I can plot density of states for another, right? So for this, what I will do, I again go to here, then yeah, again go to block data. Now in the third column, there is information regarding spin 3 and along y-axis it is, or along the first column contains this one, means energy. So this is a way that how this density of states can be plotted. So, and then again shift the Fermi energy of density of states again to this, means apply transformation that y is equal to y plus 8.715173, which is the value of Fermi energy. So I shifted this axis to then again to this axis, right? Then go to the axis properties and I set y-axis from -10 to 10. And here it's again -10 to 10, and it's, yeah. So this is a way that how up and down density of states can be plotted. There is another possibility that I can plot up and down spin separately or up and down spin collectively in one graph. Let me show you that how that can be plotted. So I need one more box. So I go to the arrange box and take its duplicate, right? Just by clicking or dragging. I clear this data. So I go to again data and then import. Yeah, go to the DOS plot data. Yeah, it is from 2:1 and then 3:1, right? So this is up and the down spin. Then again I go to the transformation, evaluate expression. I selected both the graphs, this and this, using control, and then I used again the transformation this, right? And then I changed x-axis, sorry, I changed y-axis from -10 to 10. This is, and I changed x-axis from -4 to 4. Then I again use transformation, evaluate expression. I selected second graph because this corresponds to negative spin. So what I did, I make a transformation that x is equal to -x, so that one graph comes to this side. So this is the up and the down. This is the up density of states and this is the down density of states. This is similar to this, and this graph is similar to this, but it is inverted along negative axis. So this is for the up density of states and this corresponds to down density of states. This corresponds to up, right? And this red color corresponds to down. So I can shift this from here to here. Legion can be shifted from here to here, right? So this is a way that how density of states can be plotted. You can make changes here, like this is gamma point, this is H point, this is P, and this is N point. And you can remove these additional from here. Sorry, I have to select this graph, then these points can be removed. In the similar fashion, this is gamma slash xg. What about this? This point is H point, high symmetry point H. This is P. And this is N. This is N point. So I can move this from here. So one point is missing. Here it is a gamma point. So in this video lecture, I told you that how band structure and density of states can be plotted and how data can be extracted using GNU Bands and FMPDOS utilities. And another interesting thing which we are getting in the out file, if I go to the end of the out file, then in the end of the file, if I look at it, then it contains spin moment, and this spin moment corresponds to magnetic moment. So its magnetic moment will be 2.28597 per atom. So thanks for watching this video.